So like I was saying, if you want to pay attention, feel free. If not, just keep working on your review. Okay, so this first function is a cubic, and it says graph the following functions and their inverses on the grid provided. State the transformations for each function. So first off, I'm just going to keep in mind that this is a cubic, and it's not flipped over into the axes, so I'm just going to remember that it looks like this in general. Okay, and it's going to help me remember the pattern. And I noticed that there's a -4 in the interior, which makes this mean, or it means I'm going to go to the right 4. And then there's a 1/2 on the front, and that's in the exterior of being raised to the third power, so that is a vertical compression by a factor of 1/2. So if I'm graphing a cubic, I'm going to remember the pattern is over 1 up 1, over 2 up 8, because 2 cubed, and then over 3 up 27. And then same on this side, except for it goes down. I don't think I'm going to be able to see the 27 cut in half, so I probably just won't worry about that one. Okay, so it is a vertical compression by a factor of 1/2. So I know that if I take vertical lengths, right? Because normally I say like apply the stretches and compressions first, and that's what we're going to do. But we're just applying it to the pattern instead of the movement after sketching it. So if I vertically compress by a factor of 1/2, instead of 1 it goes up a half, and instead of 8 it goes up 4. 27 cut in half is 13.5, and if I just start from the x-axis, I can only go up 12, not 13.5. So I think we're good. So we're going to go down a half and down 4. So keep in mind that your original function, like if you've got a cube root or cubic and you vertically compress it, that changes like the steepness at any time, but it doesn't change where the location of the center point is, right? The only thing that changes that is my shifts, and this goes to the right 4, and that's the only thing it does. So my center is still right there. Then I'm going to apply the pattern, because the only other transformation I had was the vertical compression, so I just basically take my cubic and use this. I'm going to go to the right 1 and up a half. I'm going to go to the right 2 and up 4. I'm going to go to left 1 and go down a half. And I'm going to go left 2 and down 4. And then I'm going to connect them. And that is my original function. Be careful that you don't go kind of wildly off and go across this vertical line, because we don't cross it until we reach 13.5, and we can't see that. So if you find yourself sketching like this, you gotta keep it. So I suggest you just go after that last point and then just draw an arrow. Okay. Now, hey, quickly, guys, do you remember how to graph the inverse? How many options do you have for graphing the inverse of a function? You have 2 options. You can find the inverse and apply your transformations to it, or you can just take these coordinate points and do what? Switch the x and the y, right? I'm going to go ahead and work it out, but then I'm going to prove it that way. So the inverse. Okay, so first I need to find the inverse, so I'm going to switch x and y, which means I've got x equals 1/2 y minus 4 quantity cubed. I'm trying to solve for y, so the first thing I'm going to do is multiply both sides by 2. So a half times 2 is 1, so that's simplify out. So I'm left with 2x equals y minus 4 quantity cubed. I'm trying to undo the power of 3, so I'm going to take the cube root of both sides. The cube root and the cube cancel each other out, so I'm left with the cube root of 2x equals y minus 4. And then I'm trying to solve for y, so I'm going to add the 4 over. So the cube root of 2x plus 4 is f inverse. Oh. Okay, so as far as the transformations, on the interior is the opposite of what I think. I know that that is a horizontal compression by a factor of 1/2. Remember, take the interior number and we cut it in half. Now, remember, this would appear in a vertical compression by factor 1/2. That's exactly right that they should be both compressions by factor 1/2. This is vertical, that's horizontal, and vice versa. And then this is on the exterior, which means it's up 4. Okay? So I'm going to remember what I'm graphing. I'm graphing a cube root. So remember that cube roots look like this. They're the reflections of the cubics, right? So it looks something like this. So if I take my pattern and I remember that I'm taking the cube root of 1 is 1, and the cube root of 8 is 2. The cube root of 1 is 1, and the cube the cube root of 1 is 1, and the cube root of 8 is 2. That. Okay, but we are applying a horizontal compression by a factor of 1/2. So in the same way that the verticals were 1 and 8, we compressed them by half, now it's the horizontals that are 1 and 8, we compress them by half. So we go over a half and up 1, we go over 4 and up 2, we go over a half and down 1, we go over 4 and down 2. So if I plot my starting point, I take, keeping in mind, I'm taking my cube root and I'm shifting it up 4. Okay? This just changes how close the points are to each other. So from my center of a cube root, I go up 4. And then I'm going to go over a half and up 1. And I'm going to go over 4 to the right 4 and up 2. I'm going to go to the left a half and down 1. And go to the left 4 and down 2. And these connect like that. And these connect like that. And there is my inverse. And if I were to draw the diagonal, so 12, 12, and then negative 6, 6. It is important that you recognize that the diagonal doesn't go from corner to corner unless this is a square, and it's not a square grid. So. And they do look like reflections across that diagonal. Okay? So let me prove right quick about the coordinate points. This coordinate point is 4, 0, and this coordinate point is 0, 4. This coordinate point is 5, 1/2, and this coordinate point is 1/2 up 5. This coordinate point is 6 up 4, and this coordinate point is 4 up 6. So I could just plot them by plotting the inverse, by plotting the original and then switching to x and y's and graphing. Okay. Let's make sure I have all my answers. It says graph the following functions. Okay, the function and their inverse. States transformations for each function. I did. I've got here, and I've got here, and I did need to find the inverse. And I guess I need to clarify that that's part of the answer. It's finding the inverse. Okay, so let's do number 2. Now, number 2 is a cube root, and we're supposed to sketch it. So first, I'm going to deal with the fact that the interior is not separated. And by that I mean I don't have my transformations separated from each other. I've got a horizontal compression, and I've got a shift left and right, but they're right now combined. And just remember that whenever I do transformations, you got A f of B times x minus c. The B and the c must be separated in order for you to be able to see the transformation. So we're going to factor out a 2, and we're left with x plus 3. So we've got a cube root function with a horizontal compression by a factor of 1/2. Again, we're going to go to the left 3, and we're going to go down 5. Okay, so I'm going to keep that in mind. I've got a cube root function. I'm going to the left 3 and down 5. So if you'd like to, we can go ahead and start there and say, there's my center point of my cube root, keeping in mind that my cube root looks something like this. No flips or anything. Okay. I need someone to. And then I'm going to apply my transformation, horizontal compression by a factor of 1/2. I do, however, know that I've already created that. So I'll go ahead and just recreate it real quick. 1, 1, 8, 2, 1, 1, 8, 2. Keeping in mind that the cube root of 1 is 1, the cube root of 8 is 2, the cube root of 1 is 1, negative 1 is negative 1, the cube root of negative 8 is negative 2. That's why we put the 1s and the 8s in there. So we're taking the cube root of the x's, the horizontal, and the y is the vertical. Horizontal compression by a factor of 1/2 again, which means 0.5 and 4, 0.5 and 4. So from my center point down here, I'm going to go to the right a half and up 1. I'm going to go to the right 4 and up 2. I'm going to go left a half and down 1, and left 4 and down 2. And there we go. Okay. So I am just going to plot the inverse by switching the x and the y's on this one just because we can, and I want to test it out. This coordinate point right here is 1, -3, so I'm going to go -3, 1. -3, 1. This coordinate point is -2.5, 4, so -4, -2.5. This coordinate point is -3, -5, so I'm going to go -5, -3. This one is -3.5, -6, so -6, -3.5. And this coordinate point is -7, -7, so that stays the same. Okay, so keeping in mind that I'm drawing a cubic, it's going to look like this. And those do look like reflections of each other across the diagonal. Okay, let's go over that real quick. Let's find the inverse. So I'm going to set x equal to the cube root of 2y plus 6 minus 5. I'm going to add the 5 over, equals the cube root of 2y plus 6. I'm going to raise both sides to the power of 30. And I'm left with x plus, maybe not with this pen. Yeah, no. X plus 5 quantity cubed equals 2y plus 6. Then I'm going to subtract the 6 over. And then I'm going to divide by 2. So guys, I do want to make sure real quick. When you divide by 2 in an expression like this, you could put like this, but what else could you do? Multiply everything by 1/2, right? And just by everything, I mean this term and this term. Your two terms are separated by the addition or subtraction. So it's 1/2 x plus 5 quantity cubed minus, so this is divided by 2, and this is divided by 2. 6 divided by 2 is 3, equals f inverse. Okay, so I've got a cubic function with no flips or flips over the axes. Okay, so that's what it should look like. That's check. Okay, I should go to the left 5 and down 3. So the left 5, down 3. There's my center point. That checks. Okay, I should have a vertical compression by a factor of 1/2, which means instead of going over 1 and up 1, I'm going to go over 1 and up 1/2, over 2 and up 8. Instead of go over 2 and up 4. Left 1 down 1/2, left 2 down 4. Cool. So I've got my, I need to state my transformations. I've got a vertical compression by a factor of 1/2, left 5, and down 3. Okay. We're ready to go on to, well, actually, I'm going to go ahead and stop the video because if I take too long on the video, the audio and the visual get off. So I'm going to stop it and then start again with the new one.